guys, so no pressure on me.
Evening, everyone.
Good evening, Dr. McBride. Dr. M.
How you doing?
Good, good.
All right. Where do you guys want to start?
If anyone wants to start with homework, go ahead. I'm done as far as I know.
I sent it. Oh,
Sorry.
that's okay. Go, Leroy. Is that you?
No, it was Steve.
Okay, Steve, go.
Thanks. I had a question on part D of 4.65. I'm not sure how to do that one.
D.
It's a multi-step process. The first thing you have to do is find the number using the quartile function, and then you have to use a little algebra to solve for k. So basically it comes from, well, the first thing you should really do is draw a picture so you know what the heck you're trying to find, right?
Okay.
And the idea is that, you know, you've got your distribution, and as always, you got the mean right here in the middle. And the idea is they want to find a value that captures 60% of your data. So if you go out some distance, right, k, from the mean, which is 250. So this little value here would be 250 plus k. And then you go the same distance here to some value over here that of course would be 250 minus k. The idea is that all of this area is 60% of your data, which means you're left with 40, right? Which puts 20% here and 20% here, because in a normal distribution, right, we have this nice little symmetry and everything works out beautifully like this. So what we then can figure out is, okay, well, that's great, because if I know there's 20% here, I know that from this upper bound down, right, I've got 80% below it, or from this lower bound, I've got 20% below it. So in either of those cases, I can now go to my quartile function here and use, make it bigger so everybody can see it. Go to the quartile function, put in my mean, put in my standard deviation, and if I want to find the lower bound, I put in 20%. If I want to find the upper bound, I put in 80%. So if we run this one right here the way it is, that tells me that's my lower bound. That's that value. So if I go back to my picture, and we can just round up and call it 208. So if this is 208, I can now solve for k algebraically, because I can just set 250 minus k equal to 208 and do some simple algebra and get k.
Cool. Thank you.
Yep. What else?
I sent a couple in to you. I am looking them up. It's Mary Ellen. Okay, so it's part C of number 4.86. Can we do that in SAS? I figured it out, but I couldn't figure out how to do it in SAS.
Kind of. It's
okay, if we're not going to have to do it, then that's okay. I just did not use it in SAS, so I didn't want to get dinged for that.
Yeah, no, you don't have to use SAS at all.
Okay.
Ever. No, yeah, it's one of those things. It's kind of like this question where you can figure out one part of it in SAS, but the rest of it requires algebra, because you basically have to use the formula for a z-score, and you have to kind of solve backwards for your sample size.
Okay, so 4.88. Oh my gosh, I have been working on that way too long. And we worked on it last night too when we had our little group together. So the exact probability for y less than 5.
Mm-hmm. Yep, so that's a CDF of 4.
Alrighty, that's all right. I'm already messed that up. I put a 5, and then I thought, how do you know that? Do you put less than that number or? Okay,
So you have to remember that when we're dealing with the binomial distribution,
it's discrete, so it's got to be a whole number.
exactly.
Oh
Yes.
boy. Okay.
Yeah. Now, if
All right.
it was the normal approximation, then of course you would do
Okay.
a 5. But because we're doing the binomial, to be less than 5 means we want 4 and below. So that's why you do a CDF of 4.
All right. So then I went to the next one, the corresponding normal approximation for y less than 5. I must be crazy, but I got 99%.
Yeah, you are crazy.
Okay.
No, that's because you probably just forgot. You probably have the 1 minus or something in your code, because if you go to,
You know what? I have to run it again because my mean is 10.
Mhm.
My standard deviation is the square root of 20 divided by 0.5 divided by 0.5 twice.
Is it divided? I thought it's the square root of NPQ. So shouldn't it be the square root of N times P times Q?
Okay. Yes, that's what I have. Okay.
And sorry, what was our sample size was 50? 20? 10?
20,
20?
20, 20. Yes.
20 times 0.5 times 0.5. And we want to find a CDF of 5.
And you want the square root of that. So that's what I had. 20.
Yeah.
Oh,
if
times,
you-
times. No, I had.
Times, not divided.
Okay. All right. I'm wrong. Okay.
And then if you run it, that's what I get, which still doesn't seem right. I can't remember off the top of my head, but I thought it was NPQ, N times P times Q. So let's see, this is, 20. Did I not have 20 in there? No, I did. (20 times 0.5 times 0.5, a mean of 10. All right. I'll have to,
X.
yeah, there it is. Standard deviation, square root of NPQ. Huh.
1 minus P. Okay.
Yeah, because Q is
one.
just 1 minus, it's the complement of P. And since your
Okay.
P is 0.5, then of course Q is the same thing. Why is that getting a different number? Because this is 488, right? I've got, it should be 0.0037, which is about twice of what we have.
Is it 10 or 20?
Is that the problem?
Mean. N is
Well, no, you need to use NPQ. Oh, you mean the mean? Yeah, the mean is N times P, so it's 20
gotcha.
times 0.5, which would be 10.
Gotcha.
Yeah, so I'm thinking maybe my stupid answer key is wrong, because I can't see I can't see any mistakes here. We want less than 5, which is the normal CDF, up to 5. We've got a mean of 10, which is 20 times 0.5. We've got the square root of 20 times 0.5 times 0.5. I don't see any problems there. Let me just try 20 times 0.5 times 0.5 in the calculator. And let's change that. Maybe something's not working here with the math. 2.236067978. Let's see if that changes things. Oh, wow. Wait a minute. Oh, shit. Square root. Sorry. Excuse my language. I've already done the square root, so that's what screwed that up. All right. Yeah, same thing we got before. So I'm thinking that's supposed to be the right answer.
Okay.
And then, of course, in the second step, they want you to get a better answer by trying 4.5 instead of 5. And that's supposed to get closer. And that's much closer, right? Because the precise answer is like 0.0059. So let me adjust my answer key because this second number doesn't seem right at all. That should be 0.012674. Okay. Anything else, Mary?
Okay, so I am on part C, normal approximation, and
Okay, so it goes back to the idea of,
I ran them with 13 and 8.
nope,
Like we
that's
had
your problem.
12, then I ran them with 8.5 and 13.5. Okay.
Right. If this is
But
the
it-
box for 8, right, and this is the box for 9, and then we go dot, 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 dot.
Is the
we
mean
have-
10?
Yes, the mean is still 10. That doesn't
Oh.
change.
So that's why I'm way off. Okay.
So if we want to be between 8 and 14 with the binomial, we only want the bars 9 through 13,
Right.
right?
So I had 8.5 and then 13.5. I ran both of those, but I used a mean of 20.
There you
So
go. That's
that
your
threw me
problem.
off. So hopefully I'll come up with the correct answer.
Yeah. So in order to get this right, you have to start here at 8.5 in order to capture that whole bar. And in order to capture this whole bar, you have to stop
And at 13 and a
at
half.
half.
Okay.
Yeah. So that's what I keep telling students that if this whole idea of when do I round down and when do I round up is giving you trouble,
Draw the picture.
draw the picture. Exactly.
I did have to do that on a couple of them. It made perfect sense.
Yeah. I mean, we are visual creatures. Human beings are visual learners by nature. So it just makes sense to draw a picture, and it's going to solidify in your mind a lot better that way.
Okay. And then my last one, I got for number 494, I got the quantile plot and all of that kind of thing. But and maybe I missed this in your notes, how to find the correlation coefficient and the p-value.
It should show up just when you run the QQ plot. So if you go
Not at the
to-
bottom where it says the MU, that's in sigma.
No, it shows up in
Okay.
it's in the actual it shows up in the plot itself. So if we go to the how-to guide to remind ourselves how to run a QQ plot, it is, where the heck is it?
Yeah, I think I got all that. The Q plot,
is.
distribution analysis, variable
Distribution analysis.
toughness. Yeah.
Okay. So distribution analysis.
Option normal distribution with insert statistics. That's all the notes that I had. Yes.
Yeah, that's what you got to do is do the
Okay.
insert statistics. So import, add toughness, options. So normal QQ plot, add insert statistics, and then down here you got to tell it which statistics to run. So we don't need number of observations, but what we need is the goodness of fit test. And then if you run that,
Okay.
it'll give you right here. There is your
P-value
Cor-
in my okay.
correlation coefficient and your
Okay.
p-value. Exactly.
Thank you. All
Yep.
right.
Dr. M,
Yes, Catherine.
Lonnie did a great job explaining this last night, but it bounced off my head anyway. The binomial distribution
Yeah.
is as in versus a normal approximation.
Uh-huh.
Okay, so they are versus one another.
Well, the normal approximation is exactly that. It's using the normal curve to approximate a binomial. So this picture here, I think, illustrates it very well.
Mhm.
The bars shaded in yellow are the binomial distribution bars, right? So each one is showing you the probability of each number, right? So you've
Mhm.
got 9, 10, 11, 12, and 13. And they all have different sizes. They're all the same width. If I could draw, they would all be the same width, but they all have different heights. So
Mhm.
for instance, if I, let me just show you what it looks like for real. So you can see bars that look better.
While you're doing that, I think where I'm messing myself up is I keep thinking binomial distribution is discrete and
It
normal
is.
approximation is continuous.
It is. Those are both
I'm
true.
not wrong. So I just totally don't understand that, which is fine. I'll get it. I'll just keep watching the videos.
So here is the binomial. All right. So we have a sample size of 20 and a P of 5. And so, for instance, if we want to be less than 5, or less than or equal to, so if we want to be strictly less than 5, we just get 4 and below. So you can see these little bars, the heights of all these bars represent the probability of each number of successes, right? So the probability of getting 10 successes out of 20 is pretty high. Well, that makes sense because we have a success rate of 50-50, so 10 should be high. And then you can see how they're all less. And in fact, you can see that the shape of this is already mimicking a normal curve beautifully. And so that's the idea, is that you have these little bars, and taking the area of all of them and adding them together is giving you probability. The reason why this graph here doesn't seem to have any area is because they're discrete, so they don't technically have to have area. You can just add up all the heights, but you could also think of them as having a width of 1, and that's, so the height is the same thing as area. But in any case, the idea is you add up all these bars, and that gives you the precise binomial. But you can fit a curve to it, and then you can find the area under the curve, and it's going to be a pretty close approximation.
Mhm.
And that's the idea of the normal approximation, is that we can take a continuous distribution, i.e. the entire smooth curve. You can draw a little smooth curve line over this, and then take the area in between 2 points, and it's going to give you roughly the same answer as if you just added up all the bars, all the individual, discrete things from the binomial.
So here's my problem. I suffer from being way too literal. And on 488, to me, the question is asking us to find an answer for one thing. Okay, in my mind, it's one thing that is both the answer for it as discrete and the answer for it as continuous. And I'm like, when would that happen?
Well, yeah, as I've said, that this is a teaching tool.
Okay.
We used to do it in the past when we didn't have computers that could do high level binomials, but
Okay.
now that we can, there's no longer a need to approximate, which is what this is. Why would we approximate when we can get the exact answer? And the answer is it's no longer done. It's no longer a practice that anybody does.
No, I got it. That's what this is. Okay.
Yeah, the whole point of doing this is to help students see the difference between discrete distributions and continuous distributions.
Yeah, so cool. Because this is part of the homework then, really, isn't it? To show us,
Yeah.
to be thinking about the continuous part of like part 3.
Yeah, exactly. Yeah, it's to
Very
get
cool.
you thinking about that for your project. Exactly.
Yeah. Thank you.
Yep, of course.
So Dr. M?
Yes.
Michael.
Michael.
I had a question back on that. It was 494B, where you had shown that the test statistic and what it put out. There was a number there. I think it was like 0.96 something or other.
Yeah.
Was that R square?
Yes,
And
that's your core. Well, no, that's R. R squared would be much smaller. So this is your correlation coefficient R. And then if you take that number and square it, that would be R squared, which is your coefficient of determination. So this is your correlation coefficient. It's basically showing you how well the dots line up on a straight line. So they're pretty good.
Okay, because running it in Excel, I got an R square of 0.9666. It was a little different than that. And then when I got R out of it, I got 0.9832.
Yeah.
It was a little, yeah. So I feel like I'm a little bit off from this number that's coming out here.
It's all in how the technology computes it. So it's all based on whether or not they're computing percentiles or z-scores, and there's going to be some slight differences between the two. So don't worry about
Okay.
it. Yeah.
May I ask a
Okay.
question?
Sure.
May I ask a question before we go off that? Okay, so I know what the 96 correlation, that percent means, but what does the p-value tell me? I mean, I see it, but what's it mean?
So a p-value tells you whether or not you can reject the null hypothesis.
Okay,
And so the p-value tells you how strongly the data kind of supports the null hypothesis or not.
okay.
Dr. McBride,
Yes.
I didn't have N, so what do you think I did wrong?
You didn't have n?
Yeah, I have.
You
the
don't
other
need
two.
n.
Oh, I
You-
don't need N. Oh,
No.
okay.
You just if I untick this and run it, then n won't be there.
Oh, okay. Okay. I was like, oops. Okay.
Yeah.
All right. Okay.
You're fine.
Okay.
Anything else on the homework?
And thank you so much for putting those 2 meet times
Sure, no
on there
problem.
for us.
Yeah, I'm glad that I'm happy to help.
We're all supposed to have access to Zoom through Franklin. It's supposed to be so easy, but it's not all cracked up to
Yeah,
be.
sometimes it works, sometimes it doesn't. Yeah, I don't know what's going on. All right, any other homework questions, or should we go ahead?
Yeah, kind of a basic one. That it's just wording. It's 472B. Is the lower, is it lower quartile what we're looking for? Or am I-
Yes. You're looking for one value that is the lower quartile, because if you've got the bottom 25%, that's the lower quartile. Yep.
That's what, okay. I just want to make sure I got the wording right.
but
What-
that's
what
the-
we refer to it as.
That's
it's
the
either-
word.
Well,
I
it's
thought
either
it was called the first quartile score.
well, it's the same thing. The
Okay,
lower
okay,
quartile and
okay.
the first quartile and Q1 are all
Okay,
three
that's what I
ways of
have.
saying the same thing. You could also call it the 25th percentile.
Okay.
They're all the same. It's like calling somebody Bob versus Robert. Okay, anything else? All right. Final project questions.
Go, Catherine. I'm not there yet. I got to finish this, but I know Catherine's ready. Go, Catherine.
Well, so again, huge shout out to Lonnie, and thank you so much for our study session last night. So for me, part 2, my questions are around part 2. And what fun to be learning Excel. This is actually very exciting. And so I have these gorgeous tables.
Mhm.
Is that okay? Or
That's exactly what I would expect and prefer. Yeah.
Oh, okay. I was afraid you wanted pretty charts and stuff like that. And I'm like, well, I haven't learned that yet, but
No. Tables is fine. I mean, doesn't it show the table in the in like the template for the final
oh yeah,
project?
the
Yes.
clean data. Yeah.
Yeah, it
Yeah.
does.
So basically all we're looking for is to finish off those columns in the table. So by all means, do that all in Excel, because it's really easy to do with a formula and then drag it to, make it repopulate the formula over and over again, and just do them all that way.
Yeah. So did that, rank the judges. Did that for each of the courts, rank the judges.
Yep.
And then I did like another level of analysis. And so I'm just going to add that in and explain why I did that. And that's what I think you're looking for. You
Yeah,
know?
exactly. Yeah.
It's like-
And don't forget, when you're doing the probability of an appeal and probability of reversal, don't forget to also do that for each of the court totals. They're
Right.
at the bottoms. Yeah.
At the bottoms. Okay.
They're at the bottom of each table, right? It lists all the judges with all their data. And then at the very bottom, it has total number of cases for that court, total number of appeals, and total number of reverses. So you have to run the same statistics on those totals so you can, see what the percentages are for each court. Because
you know what?
technically, if we were going to rate judges, it should be, we should weight it, right? Because if if a judge is presiding over a court that just historically gets a lot more appeal, that lawyers appeal verdicts a lot more than another court, then it would not be fair to judge that judge's performance on their appeal percentages flat across the board to another judge that was in a
Right.
court that almost never gets appeals, right?
Right.
You know, my total did not fill in.
Oh, well, then just do it yourself.
Yeah,
Just do the sum. Just use the sum formula in Excel.
G22. Oh, no. Okay, so then G22. No. Oh, crap. I'll mumble to myself while you all go on to figure out the formula, because it's G22 and then for me, and then $22 and then the colon. Oh, no.
Are you trying to get the totals? Because the totals just use the sum formula. So for instance, in this first court,
yeah, I'm in common, please. I'm
you
on
can
that.
just do this and then come up here to auto sum, and it sums the whole thing, and then just drag it over here and it does the same thing. So there we have appeals and reversals. And then of course, let's just drag it over here to get our total. Oops. All the way, there we go. Of course, this doesn't make sense. Go away. Go away. There you go. So there's our total number of cases in the court. There's the total number of appealed cases in the court. And then there's the total number of reversed cases for the court. So you could do the same probability, right? You could do these three probabilities based on these numbers instead of the individual judge numbers.
Oh, okay. Mhm.
So the exact same formula you would use here, you would just do it here. And the same formula you would use here, you would do it here, and so on and so forth, right? So for instance, we know that to do the probability of an appeal is simply just going to equal the number of appeals divided by the number of cases they saw. And that's the probability of an appeal. And if I change this to a percentage and give myself maybe 2 decimals of accuracy, and then take this and drag it down, it's going to do everything, including the total. So 1/1% of all the cases were appealed. And then you could repeat the process here for reversal, which would just be reversals divided by total. And then of course, the probability of a reversal given appeal is reversals divided by appeals. And drag and drop, and you'll get all of them that way.
Oh, interesting. So you have yours in the percentage, because I
Yeah.
just have all the 0.00 blah 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 blah. So I'll change them to percentage. That is easier to read.
Yes, absolutely.
Okay.
As human beings, we prefer to see these than decimals. Our brain takes a couple seconds to have to convert a decimal to a percentage, so it's much easier just to see it as the percentage.
You make everything seem so seamless.
Seriously.
Yep.
I mean, when I try it, it's like, wait, I'm missing a step, or I missed one, and then it's all wrong.
Yeah, that's just because I'm a genius.
You are.
Yeah.
It's like, I could just steal your brain, and then I'll make an A+.
I've been doing this for a very long time, including playing around with Excel. So I've got some very complicated computations that I do in Excel. So it's a good skill. That's why I'm totally for you guys using Excel over SAS for anything and everything, because it's far more marketable than anything else. I mean, when you go to get a real job, nobody's going to give 2 hoots if you know how to do SAS, but they're going to be very adamant that you know how to use Excel. Anything else from the final project? Some of you have been sending me your I don't know what scenarios for part 3, and so far they've all been looking great. So that's fantastic. Let me just reiterate to all of you here and anybody who's going to watch this video later that if you can, try and make the part 3 scenario as closely tied with your dissertation as possible. if there's nothing in your dissertation that would be a continuous variable, then still tie the scenario to your dissertation, talk about the problem that you would want to investigate, you know, how you would gather the data and all that stuff, and then just make up a continuous portion. You just pretend to create a different variable that would be continuous, even if it has nothing to do with the research question. So I want you to tackle all of those first 4 or 5 questions where you're talking about the problem that you want to investigate and the research question you come up with and how you're going to gather your data and how you're going to analyze it. I want you to do all of that as if you were doing a dry run of your dissertation, because then when it comes time to do your dissertation, you can literally take the work that you've done in this project and just expand on it, because that's all the dissertation is taking each of those, you know, like 4 questions and turning them into, you know, almost an entire chapter, right, of your dissertation type of thing. So it just gets you started thinking about that. Now, obviously, if you're not far enough along in your studies that you know what your dissertation is going to be about, then you're just going to have to make this whole thing up from scratch. And then again, if your dissertation, if you're not thinking about gathering any kind of continuous level data, the first thing I would say to you is reconsider that. And the second thing I would say is that's fine. Still do all the questions based on the discrete data that you're going to collect, or even if you're going to collect only qualitative data, that's fine based on that. But then create a fake scenario for something that you would collect that would be continuous, and then use that to answer the last few questions where you're making up what's the probability that something is less than this, what's the probability that something is greater than this, and blah, 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 blah. And again, you do not need answers for those questions. You just need to create the question and then show a graph that illustrates what the answer would be. It's all about making sure that you understand what it means to find the probability of less than something, the probability of greater than something, the probability of in between something, or, you know, what number gives me the 10th percentile, those kinds of things, right? So it's just being able to visually represent those types of questions. All right. Anything else question-wise?
Dr. McBride, Lonnie.
Yes, Lonnie.
2 questions. I was reading through the scenario again.
Or should I call you Assistant Professor McDonald?
Seriously.
No, they're giving me way too much credit. You know, I stuck my foot in my mouth like 15 different times last night. We won't even go over that, but that's okay. The high point is when my 8-year-old son said hi and did a couple other things.
Yep.
We appreciate you, Lonnie.
In the final project, the judges for 3A and 4, or the judge 3 and 3A, they're the same person. I'm not quite sure. Do I combine them?
That's where I leave it up to you. So
Okay.
obviously the judge gets ranked twice within each court, because if you want to just rank everything within each court, or sorry, you're supposed to rank everything within each court, you can just think of them that way. It's up to you. I've had some students decide to do a global ranking of all the judges, which is fine. I've had some students decide to rank them within each court, which I think is the easiest, because then you don't have to think about what to do with 3A and 3 and 4. If you're going to rank them overall, then it would be up to you. What do you do? Do you combine their caseload? I think that would probably be the most logical thing, and just have a total number of cases, total number of appeals, and total number of reversals, and go from there. It's up to you. Whatever you decide, just justify your decisions.
Okay. And my next question on part 3, I decided to take the plunge and just try out StatCrunch, because you've used it a couple times and I saw it a few times on the videos just to see how it worked. Is it okay to use StatCrunch for the graphs?
Oh, God, yes. Yeah.
Okay.
I can't think of a better, easier, quicker tool to get those graphs, than StatCrunch. If you just go calculators, normal, right? And here's, let's be less than 0.25. There we go, right? And if we want to do in between, there's my in between, and just, change my mean and standard deviation, whatever. But yeah, it's beautifully easy to get these beautiful little bell curves out of StatCrunch.
And
But for those
with
of you that don't want to get StatCrunch, you can find them online as well.
and final smaller question, I'll admit it, I invented like the mean and the standard deviation and was going to justify that and put it in the whole scenario. Is that
Yeah,
Oh,
no,
okay.
that's exactly what I would expect you to do. Yeah,
Okay.
the whole thing is made up because nobody's going to have that data already. Now, if you're that one rare student that's already far enough along in your dissertation that you already have the real data, then by all means run it on the real data. But 99.99% of you are going to have to make everything up. So yes, by all means, make up the mean and make up the standard deviation. If you can justify it, great. If you can't, don't feel like you have to, because a lot of students are going to make up the entire scenario completely from scratch, right? I mean, everything is make believe, so it would be hard to justify anything because you're basically pulling everything out of your hat. So if you can justify it, especially if it's related to your dissertation, and even though you're making up the numbers, it's still kind of rooted in some sort of real world scenario, then by all means do that. But it's not necessary, and I will not take off points if it's there or not there, or if your justification doesn't, like if I'm not going to disagree with it because it's your made up scenario. So yeah.
Got it?
Hey, Lonnie, did it charge you for StatCrunch?
Yeah, for students, it's like $15 for 6 months or something like that, I believe.
Yeah.
Oh, that's not bad at all.
No, it's not bad. And it's a great tool, especially if you're going to go on and take 810 soon. This is what I like to tell my students. Even if you go on to 810 and the professor there really wants you to do things in SAS, well, chances are whatever professor you get for 810 is not going to allow you to turn things in early and get feedback like I do. That's a very me thing. So wouldn't it be nice to have a way to get some sort of validation that you got the right answer? Well, there goes StatCrunch, right? So you run something in SAS, you get an answer, and then you go and run the same thing in StatCrunch, which is a million times easier, and get an answer out of StatCrunch and go, oh, it's the same thing, yay, or oh crap, it's totally different. So it's probably worth it just for things like that. Now, of course, you can run just about everything in Excel to double check your work as well, but and learning those skills is awesome. But most of you have lives and don't have time to learn all that Excel stuff. And this is a much quicker, easier thing to learn, especially because there are literally thousands of videos on YouTube showing you how to do anything and everything you would want to know how to do in StatCrunch. So that's one of the reasons why I highlight it, and it's in a lot of my videos. And I tell students that it's probably worth the 12 to 15 bucks that they ask. For you to get it for a short term, to use it just to get out, get through 807 and 810.
Yeah, I highly endorse it. With the stuff that I did today, it took me maybe 15 minutes at the most.
Yeah, it's got a pretty shallow learning curve. It's pretty easy to get up and running and figure things out, because pretty much just about everything you're going to do is going to live underneath the stat menu, and then from there it's pretty obvious. Oh, I want to run some t-stats, it's right here. Oh, I want to run some summary stats, it's right here, right? It's all pretty easily laid out. So I love it. It's a Pearson tool that comes with some of their statistics books, and that's how I was first introduced to it about a decade ago, and I've been using it ever since.
So Dr. McBride, can I ask you a question?
Of course, Tiffany.
Did we pass that test that you'll keep?
Oh, good question.
Oh, that's a great question.
Yeah.
I have not seen the numbers yet. What happens is the school will send out an email and tell me how many people have done it or not done it, and ask me to remind people. And I should get that email probably tomorrow. But if I don't, there's a link somewhere. I have to go hunt it down. I can go in and it tells me how many people have submitted it. But I gotta imagine it's you got to be close, if not there, because it seems like everybody's You know.
We're at 80%.
Oh, awesome. So you can see it. Fantastic.
Yeah. Well,
Wow.
what I can see are all the evaluations I've turned in my,
Nice.
yeah. And so we're currently at 80%.
Oh
So
my
that'll be
gosh.
that'll be
Yep.
16 out of 20. So there's only 4 people that are holding you back.
Yeah, let's hunt them down.
That's
Well,
right.
We need to set out another push.
That's right.
I already did one.
It's pitchforks and fire time and torches time. Get the angry mob going.
What about the where you're letting students turning their assignments in? Remember how you said the last class didn't follow directions? Did we follow directions for you?
Yeah, I've had a couple people that turned in things that weren't named properly, but for the most part, you guys have followed directions
Good.
very well. You should be very
Oh,
proud of
okay.
yourselves.
Yeah, I told my faculty advisor, and she said, "What's this professor's name? I want to keep his name so I can tell my other students." I said, "He's
Uh-huh.
like the best." He's like the best. He lets us turn it in early.
Yeah. Just I think he meant he wanted to warn his students to stay away. This crotchety old bastard that requires me to name things properly. Yeah. Yeah, you guys have done really well so far. I think you guys will be fine. The last thing I want to, if there's no other questions, the last thing I want to leave you guys with in terms of the final project is don't stress out about it, right? So many students put way too much into this. It's really a lot easier than you think. Part 2 is going to be so simple because it's really just a matter of, I mean, it's literally what I just showed you in Excel, you know, doing it 2 more times and then doing it in each of the 3 courts. And then, you know, all you have to do is if you wanted to do something simple, you could literally just go, okay, I'm going to sort, right? I'm going to go to data, I'm going to sort, and my data has headers, right? So I'm going to sort it by the probability of an appeal, because that's the only one I have filled in so far. And I'm going to go largest to smallest or smallest to largest. I'm going to go smallest to largest. Okay, so now this person had the least amount of appeals. Obviously, this moved the totals up. I would have been better if I hadn't done that, if I hadn't highlighted the whole thing. But anyways, since that's the smallest, then he gets a 1, and then or she gets a 1, and they get a 2. And then you could literally just go zing, and everybody's ranked, right? So it's very quick and very easy, and you don't have to don't put more energy into part 1 and 2 than you need to. Just bang it out. It's pretty easy stuff. Part 1 is really just a rehashing of a lot of the homework that we did this week and last week. The only one that's going to be difficult is the one that asks you for the probability of, I think it's 4 or more or 5 or more, buying 4 or 5 more tickets for, I don't know, it's like part question 4 or whatever. And even if you get it wrong, it's like, you know, 5 points out of a 200 or whatever. So it's no big deal. And then part 3, again, don't stress out about it. I'm very lenient on part 3 because the whole point of part 3 is to get you guys thinking about your dissertation. I want you guys, the best piece of advice I ever got in grad school was you should be thinking about your dissertation on day 1. Now, that doesn't mean you have to have a topic formulated on day 1. It's you should be thinking about it, because everything you read should be something that's going to go in your lit review. You shouldn't waste your time reading anything that isn't going to be in your lit review. So if you have even an inkling of what your topic is, then everything you read, you can already start thinking about, oh, I'm going to highlight this because this would be something that would go really good in my lit review. Oh, I'm going to highlight this because this is going to, you know, talk about my methodology, or whatever it is. You're already setting the groundwork for that lit review, because the lit review is literally going to be one of the hardest portions of your dissertation, because it's just so much damn reading and so much, you know, synthesizing of information, because you're supposed to take in literally dozens and dozens of other pieces of information and somehow synthesize it all together. And that's a very time consuming task. So if I can get you thinking about your dissertation early and get you writing about it early, that is going to be a huge bonus for you, because it'll start taking some of the weight of it off your shoulders. And so don't stress about part 3. I grade them very leniently. It's basically, did you do it or not do it? If you did it, you get in the points, because there's no right or wrong answer. So I'm not going to be grading it on content other than, did you just do it? Because they're all going to be separate. They're all going to be individual to your dissertation. So there's no wrong answer is basically what I'm trying to get at. So, deep breath, calm down. It's not that big of a deal. Jump into it and try and I don't know, learn as much from the process as you can. Don't think of it so much as a stats assignment as a dry run or a beta testing of your dissertation.
There
All
he
right.
goes again, making things real simple for us.
That's what I try. That's what I try.
All right. Thank you so much for all your help.
That's, of course, guys. Thanks for being a great class. And even though this is our last meeting, remember, I'm not going anywhere. So send me
we'll post
questions and things like that.
We
Yeah,
will.
absolutely.
Okay. All right. Thank you. Good night, all.
Good night,
Yeah,
everybody.
Thank you, Dr. McBride.
Thank you.
Thank you.
Thank you,
Thank you.
Dr. M.
Meeting was
Good
a
night.
good meeting.